In automated vehicle washing, water is either an asset or an expense. It depends on the way you look at it. But one thing is certain. Water will continue to become more expensive and an ever more scarce commodity. Water used during vehicle washing, chassis washing and wheel washing is typically collected in either a sump or is collected via a pump out of the silt trap. This water is then filtered and treated with varying degrees of sophistication, in combinations of settlement traps, hydrocyclones and flocculation systems, depending on the finished water quality required. The cost of clean water is spiralling, and its abundant supply is not guaranteed in the long term. There are two ways to reduce water usage. One is to increase the spray pressure to achieve the same cleaning effect but using less water. There are still companies that use low pressure 5 to 10 bar instead of 40 to 70 bar. The other is to use recycled water. It increasingly makes both economic and environmental sense to use recycled water. But therein lies a potential problem. Water filtering and recycling systems are good, but occasionally even the better maintained systems break, with potentially devastating consequences. Pumping water at high pressure is a difficult task, even when it is clean. Water is corrosive, a non-lubricating fluid that causes wear to dynamic seals. The piston and plunger pumps commonly found in high-pressure wash systems are relatively high maintenance items at the best of times, but are particularly susceptible to damage through pumping solid particles, or worse still, by running dry. Even under ideal conditions, the dynamic mechanical seals wear and need to be replaced regularly. But in run-dry conditions, or when required to pump dirty water, this wear accelerates rapidly. Not so with Hydrocell sealless diaphragm pumps from Wanner. These pumps, proven in thousands of high-pressure car wash applications, continue to operate under run-dry conditions and are not detrimentally affected when required to pump particles in dirty water. A Hydrocell pump will even function under temporary vacuum inlet conditions, a circumstance that destroys lesser pumps. To aid cleaning, water is often heated to 80 to 95 degrees centigrade, and this significantly increases its corrosive potential, creating problems and increased maintenance requirements for pumps with dynamic seals. The Hydrocell sealless design requires far less maintenance under such conditions. A wide range of chemical additives are also used to enhance cleaning performance. Chemicals that can cause problems in dynamic seals but have no detrimental effect on the Hydrocell pump. The flow from a Hydrocell pump can be controlled very accurately, as flow rate is directly proportional to pump shaft speed. This means that by simply controlling the motor speed, the cleaning process can be finely controlled, minimizing energy and water usage. The maintenance requirements of a Hydrocell pump are minimal and easily carried out. The initial cost is competitive and the life cycle cost is best in class. To learn more about Hydrocell pumps, visit our website today.